Now this has got the answers as well. The answers are at the end. Okay, so let's look at this guy here. Methyl benzoate, okay, that's built on benzoic acid, and the alcohol is methanol. So this is the acid alcohol. And the way you'd make this would be the three ways to make esters, remember, using the acid chloride, and using the anhydride. Those are the three ways. Starting with the acid, it's the least yield. Acid chloride is the most yield. And then the anhydride is in the middle. So to make this, let's just do it with the acid. So this is benzoic acid. That would be methanol. Okay, so we have sodium acetate or sodium ethanoate. That's going to look like that was another mistake frequently in the Benedict's reaction. Remember, it's done in an alkaline environment. So that means that acid is deprotonated. It's O minus. A lot of you put OH there. So as soon as you see the O8, that means it's either an ester or an ion, a sodium or potassium salt. So since this has no cation out front, it's going to be an ester. So this is the alcohol it's built on. This is the acid. So this is a 4-carbon acid. So we have the ethyl alcohol and butanoic acid. Okay, you need to know that chart of acids I gave you, fatty acids to know. Like this would be either the alpha version of the linolenic acid or the gamma version of the linoleic acid. This would be the gamma one. Okay, we have another O8, so that means it's ester or salt. So This is the alcohol part. Acid part. Whenever I draw esters, by habit, I always put the alcohol part on the right, but you can just as easily put the alcohol part on the left. Totally up to you. This is the alcohol part. And then let's make this with the anhydride. So we have the same alcohol, but it's the anhydride instead of the acid. Remember, an anhydride is like two esters stuck together. Okay, and it's a 5-carbon acid. So 1, 2, 3, 4, 5. So that's the anhydride. That would be the acid. I mean, the alcohol. Glycerol is the alcohol backbone for triglycerides and phospholipids. So that's trioleate is the name of a triglyceride with the fatty acids 3 oleic acids. So we have the glycerol backbone. Let's need a lot of room for this. That's the glycerol. And then oleic acid is 18 carbons long, 1 double bond, and that's at carbon number 9. So we have, there's a double bond at carbon number 9. Same with all these others. So this would look what olive oil would look like. If you were to analyze the triglycerides in olive oil, it would be trioleate. Choline. Choline is what's in lecithin. It's the part that makes the phospholipid part. So choline looks like this. There's an alcohol on one end. So it's a 2-carbon ammonium salt. And we haven't got to those yet. It'll be unit 4. But anyway, that's what choline looks like. This is going to be lecithin. So up here, it can be any fatty acid. You can put stearic acid, which is the simplest one. That's just plain old 18 carbons, totally saturated, no double bonds at all. Where you can mix it up. But the important part is down here. That's what makes an emulsifier. Definitely we'll be asking questions about emulsification on Thursday. Emulsifier requires 2 things, no exceptions, a very nonpolar part and a very polar part. So this is going to represent the polar part. The nonpolar part is the stuff up above. And here are all the answers. Okay, so this first one up here is 1, 2, 3. That's the acid part. And it is a ester, 2-carbon ester. So that's going to be ethyl. Propanol 8. This is the sodium salt of an acid, and it's also a 3-carbon acid. So it's going to be sodium propanol 8. Now here's an ester with the alcohol on the left, acid on the right. So this is a 1, 2, 3 carbon alcohol. So it's going to be propyl. 1, 2, 3. 3-methyl. 1, 2, 3, 4. Butanoate. Okay, this has got 1, 2, 3, 4, 5, 6. This is 20 carbons. So I included our fatty acids to know here. Now that had 4 double bonds. These are the locations. So there's two ways to name it. Icosa means 20 carbons. These are the carbon locations of the 4 double bonds. So it's icosa 5,8,11,14 tetraenoic acid or arachidonic acid. This is a real important one because this is the precursor to a prostaglandin, which is how non-steroid anti-inflammatory drugs work. It requires arachidonic acid as a precursor. This is like your dry labs multiple choice. Okay, this is glycerol. Now, this is not based on benzoic acids. It's based on cyclohexanol. So this is the acid. This is the alcohol. So it's going to be cyclohexyl, 4 carbons, butanoate. Okay, here we have just plain old acid, 1, 2, 3, 4, 5, 6. So it's going to be a 1, 2, 3 methyl. Hexanoic acid. And then we've already done these. Now I'm going to go through some of these multiple choice questions. Okay, so we have a triglyceride here. How do you know it's a triglyceride? 3 carbon backbone, ester. So these are the alcohols. This happens to be glycerol. And these are what? 3 fatty acids. So the question is, we replace this boxed area here with this here, which happens to be choline. What will we make? Well, this is the phospholipid I want you to know. This is a lecithin. So the answer is going to be phospholipid. Now, the first one was a plain old lipid. This one here does not have a glycerol backbone. It has a different backbone. Okay, now this is again lecithin. We have choline here, the diphosphoric acid ester, and this is a fatty acid up here, glycerol. So this would be B. No answer. Okay. Okay, the products of the reaction of a triglyceride with sodium hydroxide can be converted to the products of the hydrolysis of the same triglyceride. That's called saponification. Saponification is when the ester comes apart. So number one, you have to have an ester. Number two, it has to be in an alkaline environment, pH greater than 7. So it's going to be plus water. Now, once you add an acid here, it converts to the acid because this here protonates that salt. Now, if you remember the story about Crisco shortening, vegetable shortening, the way they hydrogenated the fatty acids produces trans fats. They don't do that anymore because they were going to be put out of business. So they do it a different way now. So that's called a hydrogenated vegetable oil. Now, it says the following structure is an example of what type of lipid. Well, it's definitely not an oil. Oils are triglycerides. It's not a steroid. Fat has to have triglyceride. So the only thing left is a wax. Now, this is not the example of a wax I gave you. I gave you the example of a wax much longer than this. So this is a poor example. These should be like C20, 24. Same with this over here. Really, really long alcohols and fatty acids. Because waxes, as you know, are very solid at room temperature. And the reason why they're solid at room temperature, like a candle or beeswax, is because of these really, really long carbon alcohols and carbon acids. We did not cover this in lecture. Now, the answer could be A or B. Cell membranes are phospholipids. That means they have the glycerol backbone, 2 fatty acids, and choline with a phosphoric acid ester attaching it to the backbone. But they can be saturated or unsaturated fatty acids. So the real answer should be A and B. And this is going to be good old lecithin again. So the phosphoric acid ester is what attaches the choline to the backbone. I already mentioned wax. When you hydrolysis means the esters coming apart. So you're going to get a fatty acid plus a long chain alcohol. Okay, wax is different from fats and oils. Now, fats and oils are triglycerides. Okay, so they've got that glycerol backbone. Waxes don't. Okay, so these guys are triglycerides, and this is a simple ester. So, A, no fatty acids are produced upon hydrolysis. Okay, acids are produced on both of them. They're not easily hydrolyzed. Under alkaline conditions, both are hydrolyzed. The alcohol produced upon hydrolysis is not glycerol. That's right, because when you hydrolyze triglyceride, you end up with glycerol as the alcohol. When you hydrolyze the wax, you get the single alcohol. Oh, wait a minute, it's not B. C. Now, this is more like what wax should look like. Nice, long, this is what, C16 acid, and this is a C18 alcohol. So this is definitely a wax. So we have a triglyceride, alkaline conditions. F3 is not necessary. Organic chemists and biochemists never balance equations, but theoretically you should have a 3 there. So when we hydrolyze, the ester goes to the alcohol and acid. If it's under alkaline conditions, you get the acid's salt. This is going to be A. So remember, ester plus base or alkaline gives you the acid, salt, and the alcohol. Glycerol is an alcohol. And when you hydrolyze a triglyceride, so whenever you remember now, when you see fat or oil, these are both triglycerides. The alcohol is glycerol. The acids are whatever the fatty triglyceride was put together with. So we're going to get glycerol plus the fatty acids. Okay. Oils, as opposed to fats, are usually plant-based. Fats are animal-based. Also, fats are saturated, oils are unsaturated. So this is saturated, 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 unsaturated. That's why it's C. If this was fat, then the answer would be A, B, or D. Okay, fats or oils, then ester. Okay, so the lowest number of carbons is going to have the lowest melting point. So we just look at the carbon counts, which has got the lowest. So we have 39, 33, 29, 31. So that's why it's C. Now, if you throw double bonds in there, things change. When you have a double bond in there, it also lowers the melting point, even if the carbon numbers are greater. That's why they were very specific in listing only saturated fats. And this would be the highest carbon count. So you're looking at now D. Now, the way fatty acids are made in our bodies, or I should say biologically, in both plants and animals, is by twos. So that's why they're always even. Where did everything go? Now, an example of a simple lipid, I mean, the answer obviously is wax, but it could be a steroid too. They're a non-saponifiable steroid, lipid, because there's no ester in there, but it's still simple though. Which of the following is a characteristic of a lipid? Most lipids are not soluble in water. Some lipids are waxy, not all of them. Some of them are. Lipids are found in both plants and animals. Most lipids are low density. That's why soap floats, as an example. So the only one is B. All right. Those are the examples I have for you today. So again, regarding Thursday, you're going to have 2 hours. I forgot. Did I put a practice test up?
over in class on Tuesday? I see it on here, but I don't see an answer key for it.
Okay, let me look. Well, if it's not up there, I'll put a practice test up. Well, the one I went over on Tuesday, I put that up, I think. Okay. So you're saying the video is there, but not the PDF? Oh, the answers. Okay. Send me an email to remind me. I'll post the answers as well. Okay. So 3x5 note card, both sides. I'd recommend doing it in pencil and bring your big eraser. Except for those of you who are daring. And again, congratulations on the test. You guys did well, except for that one issue. I think everyone, there were 2 people got hundreds. A lot of people got, have an 89% average. A fair number of people had A's. So, okay. So any questions about anything? Oh, one other clarification. Regarding Lab 7. Lab 7 is 3 weeks long. So there's going to be 3 parts to Lab 7. That's Lab 7 in your packet, Lab 8 in your packet, and Lab 8B, which I posted. Those are the 3 parts. And Lab 8B is what we're doing today, which is a titration. So at the beginning of lab, I want to talk about what is a titration. You had that theoretically in, who remembers titrating in 305? You did do it then, right? Okay, good. So this will be a review. Okay, I will see you guys in lab.